was a software development engineer on the mobile platform team at a travel booking company. I was assigned to reduce Android startup because customers were abandoning the app before the home screen loaded. The initial goal was narrow: defer 2 analytics libraries and improve median startup from 3.8 seconds to below 3 seconds. While profiling the application, I found that the libraries were only part of the problem. Every product team had added its own initialization task, and the app started all 43 tasks before showing anything, even though most were irrelevant until a customer opened a particular feature. I saw an opportunity to do something broader than optimizing 2 libraries. Create a startup platform where the app declared what capability was needed, dependencies were explicit, and non-critical work ran only when required. That could improve startup now and prevent it degrading as teams added features. I decided to pursue it, but I didn't ask the organization to pause feature delivery for a full rewrite. My objective was to prove the model within 6 weeks, get startup below 3 seconds, and make at least 5 high-cost tasks demand-driven without increasing crashes or delaying authentication. First, I instrumented every initialization task for duration, dependencies, and first use. The data showed that 27 tasks completed before the home screen but were not used in the first minute by more than 90% of sessions. It also showed 3 hidden dependencies where one team's task read state another task created. I considered a fixed reordered list, parallelizing everything, or a dependency-based registry. Reordering was quick but would decay with the next feature. Full parallelism made the hidden dependencies race. I chose a small registry that classified tasks as blocking, post-render, or on-demand, with an explicit dependency graph and a time budget for blocking work. The platform lead worried this was too much scope for a startup project. I built a 2-day prototype around 6 tasks and replayed 10,000 startup sequences. It reduced time to first screen by 31% and surfaced 1 dependency cycle before deployment. That evidence earned agreement for a bounded pilot, not a company-wide mandate. The hardest obstacle came from the loyalty team. Their library refreshed membership state at launch, and they believed deferring it could show the wrong price. I worked through the customer journey with them and separated the need to read cache status before rendering from the need to refresh status from the network. We kept the cache read blocking, moved refresh post-render, and added a rule that checkout waited for a current status if the cache exceeded 15 minutes. My first registry API was also too flexible. Teams could supply arbitrary code to decide when a task ran, which recreated hidden logic in a new place. During review, another engineer showed that 2 examples could produce circular runtime decisions. I replaced the callback with 3 fixed lifecycle triggers and made dependencies static, accepting less flexibility for something engineers could reason about and validate in the build. I migrated 8 tasks with their owners and created tests for cold start, deep links, logged out use, and offline conditions. Rather than force every team onto it immediately, I published a scorecard of task cost and first use evidence. Teams could nominate the next migration, but any new blocking task needed a measured customer reason and platform review. Within 6 weeks, median startup fell from 3.8 to 2.4 seconds on the target devices, and the slowest 10% improved from 7.1 to 4.6 seconds. Crash-free sessions stayed within 0.1 percentage points of baseline. The original 2 analytics libraries accounted for only about 280 milliseconds of the improvement. The broader task model delivered the rest. Over the following quarter, 11 product teams migrated 31 tasks. The app stayed below 2.6 seconds despite 2 major feature launches, and startup-related abandonment fell by about 9% in the target device cohort. The registry became the supported mechanism, although 2 specialist tasks remained outside it because their native libraries could not be safely deferred. The lesson for me was that thinking bigger still needs a bounded proof and an adoption path. I now separate the long-term mechanism from the first reversible slice, so a broader idea can earn support through evidence instead of depending on enthusiasm alone.